Yes. Hello, everybody. Can the people on Zoom hear me? Oh, there is a echo. Is it echoing here?
What? Yes, I can hear you.
Sorry for that issue. So, welcome everybody to the session on keeping your data safe with Google Cloud and more precisely confidential computing, which is a combined effort of Hackdavis, SacHacks, and GDSC. So, firstly, introduction. My name is Shyam Agarwal. I'm a computer science engineering major, and I'll guide you through the process. So first of all, let's see how to get the credits for the QuickLab platform and your free 1-month subscription. So open an incognito window. And the link is go.quicklabs.com/cloudstudyjams/2020. Scroll down and click on GCP Essentials Enroll. Can everybody follow me? If there's any doubt, you can just raise your hand and yeah. The link is go.quicklabs.com/cloud-study-jams-2020. So the code for the workshop is this.
The link is also given at the bottom, so you can follow.
Is everybody good? People on Zoom? Okay, assuming that, I'll move on. And then you need to verify if you're a robot or not. So just see that. This, I guess. Oh, sure. Are you good? Okay. Okay. Now press this button, enroll in this quest. And sign in with Google. The ID is never gonna give you up.
Okay, one second.
Okay. So sorry for that. Enter your password. And again, verify if you're a robot or not. Is everybody good? People on Zoom? Oh, you need to go to GCP Essentials, and there's a button called Enroll. Okay, then just start the lab. Again, verifying if you're a robot or not. And let it running. Now I would invite the GDSC lead, Aditya Ravi, to just introduce what GDSC is so that everybody has an idea about that.
Getting applauded for just coming up on stage to just market something is amazing. Trust me, you'll like it. Yeah, so I guess welcome to GDSC and SacHacks collaboration for activists. So yeah, let me just talk to you about GDSC in case you haven't heard of it before. GDSC stands for Google Developer Student Clubs. So what we are is we're a part of this global community, right? It consists of over 1,500 chapters just like us. And we're affiliated with Google, so that means that we get a lot of resources from Google, just kind of help students, get involved in Google technology, build a few projects, learn it, and so on. And our particular chapter of GDSC is focused on, I'd say, three main things, right? The first thing is our technical sub-team program. So what happens is, when you join our technical sub-teams, you get put into this group of people who are interested in kind of the similar technologies as you. And they're just free to work on whatever project they want, whatever technology they want, right? It doesn't have to even be related to Google, right? It can be AWS because a lot of people use it, a lot more than Google Cloud, but let's ignore that for now. Yeah, so basically this is an amazing experience for you to just have someone to push you and just build a project, just put a few things on your GitHub. Because like ultimately, when you have to do your internship applications or your future job or whatever, right? Like one of the things that matters the most is like having a lot of projects on your GitHub, and this will like help you, put something in there. Because like one of the things that I know a lot of people face, and even myself, is that like when it comes to working on projects, when we don't have someone to kind of push us and guide us, and like we don't have a team to kind of work through it, we kind of tend to slack off, right? So the technical sub-team program really helps you a lot when you just have a bunch of people who's going to work with you. So think of it like a hackathon, but you could build something that's you could, I guess, like put on that's more fully fledged, right? You have a lot more time to work on it. And I guess the next thing is our technical and non-technical workshops. So basically, right, if you don't have enough time to, build like a fully fledged project, or like you're pretty good at just building things on your own, well, you could still come to a workshop, right? And our workshops cover a variety of technical and non-technical topics, like AI, ML, web development, whatever you name it, we have something for you. And then our other type of workshops are non-technical workshops. So what these are things that you generally kind of do outside of the technical stuff, like outside of coding, that will help you get an interview, get a job. So some examples of workshops like that we've done in the past is this LinkedIn profile workshop using a LinkedIn ambassador we collabed with. We kind of went over the stuff that companies look for in their LinkedIn profile when they think of hiring you. And the next thing is a GitHub workshop. So this is a workshop that was collaborated between like a bunch of the GDSC, right? We had like 5 different colleges collaborating on this to get this like amazing guest speaker. So she's like she is a startup CEO who primarily uses GitHub profiles to make hiring decisions. So everyone who attended it found it like pretty useful, to know how to structure the GitHub profiles, just so that it catches the eye of whoever just so happens to be looking on it. And then the other thing is like study jams, and I guess like workshops like this, which kind of give you a 1-month free subscription to Quick Labs. So Quick Labs is what Google calls its preferred learning platform for Google technologies. So, whatever Google technologies you might want to learn, Google would very much rather that you learn it through that platform because it has like these hands-on labs where you actually work in like a Google Cloud account that Google has provided to you, instead of like some simulation or just learning through a book or whatever. So like it just gives you some actual hands-on experience. And being a part of GDSC, you might actually, you by just attending like one of these workshops every month, you can actually get like a free subscription year round. It'll cost like $600 outside of GDSC, but just like being attentive here, just like participating with us, you can actually get it for free, and it's a great resource. And yeah, another thing is like we're also hosting SacHacks this time. We're co-hosting it with IBM, but like we're gonna talk about it after the end of this workshop, because I mean, after all, you're here for this and not to hear me just market. So I'm gonna hand over the stage to Shyam and Mana. They have an amazing workshop put together today for y'all. So enjoy.
Thank you. So coming back to the lab, just end it over here and submit. After a few refreshes, you would see that you would have got a 1-month subscription. Did it work for everybody?
Yeah.
Okay, people on Zoom? Awesome. Just give me a minute to connect the entire. Okay, so before we do hands-on cloud computing, let's first talk about what cloud computing is and why do we really care about it. Oh, it doesn't show it on the screen. Why is it showing? Okay, so let's talk about what cloud computing is and why is it necessary. So in this age of information technology, we are highly dependent on a lot of online services and tools, be it ordering food online or online classes. Be it ordering food online, online classes, or some sort of bank transaction, a lot of our highly sensitive information is present at different locations online. Now, being responsible developers, it is our responsibility to ensure that the user's data, which we are working on, is not compromised at any stage. So can somebody tell me what is one possible solution to keep the data safe? And you get chocolate for participation.
Chocolate rock.
Just guess it. It's very easy. It was, sorry, Zoom people, I cannot give a chocolate, but yeah. It was mentioned on the screen a few months ago. That's the topic we are here for. Anybody?
Cloud computing?
Definitely, it's cloud computing. Mana, please give chocolate. Congratulations for answering the most difficult question. Okay, so first let us talk about why this field is very exciting. This field is exciting, firstly, because there's a lot of cross collaboration that's happening, especially in the technical space and the world around us. Secondly, the concept of confidential computing actually complements the current encryption system standards. That is, it is not something new. That is, if we implement this technology, we don't have to change many things. It just complements the current system. So let us look at what the current encryption system looks like. So we have some data which is stored in a storage device. I'm just taking random numbers 1, 2, 3. When it is stored in a device, we call that this data is at rest. There might be situations when you want to transfer this data from one point to another, and we say that the data is in transit. So the thing is that the current encryption system works very well for these things, because the current encryption system provides us with ways to prevent unauthorized access when the data is at rest or when the data is in transit. But what about the scenario when our code is being run on our data? What if somebody tries to access my data when the code is being run on it? Unfortunately, the current encryption system doesn't help with that. And therefore, we have confidential computing, right? So first, let us look at the parties or the groups that we need to save our data from. One of them is malicious actors. These are people who try to steal your information by things like web scraping. There are things like memory dumps. So basically what happens is, if while running your code, the code crashes, memory dump is a system or a mechanism by which your data gets stored in a storage device. So now assume you're working on a highly confidential data and your program suddenly crashes. All the data in your RAM gets stored in a storage device. Everybody knows what RAM is, right? Random access memory. So all the data from your RAM gets stored in a storage device, and it's very easy for somebody else to access it. Next thing is the inevitable threat, which is insider threat. Who knows? The software developer you're working with is actually trying to steal some information from the code base while the code is running. You need to take care of that as well. And one more important thing is collaboration. You often want to collaborate with some software vendor or a technology partner because we all know the strength of collaboration. And I guess Hack Davis, GDSC, SacHacks, they all represent the same. So I'll just write vendors or tech partners. So we saw that these are the 3 major groups we need to save our data from. Now let's define what confidential computing is and see how it helps us. So the definition goes like confidential computing is a hardware-based technology that performs physical partitioning of memory at server level. Now let's just simplify this. Can somebody tell me a part of the memory which has last in first out or first in last out order? Anybody? Who answered that? Okay. Yeah, that's the right answer. You get a chocolate. Okay, so I have a stack over here. I am writing my hardware in the at the bottom, my middleware in the middle. So middleware is like a software that bridges the gap between operating system or a database and the application software. And I'm just assuming that I have a containerized abstraction on the top. So containerization is basically a form of virtualization where we use a single shared operating system to give isolated spaces to different applications. These isolated spaces are technically called enclaves. So this is enclave 1, 2, 3, and so on. Now let's zoom in and see what this enclave does. Let's say this is my enclave. You can consider it to be a black box. So what it basically does is, it has the data that we just talked about initially. And it also has the code, the method, the procedure, or the techniques that work on this data. Now, as we said that we need to prevent our access from 3 major groups. Can somebody tell me the 3 major groups that I just mentioned beforehand?
Hardware, middleware, and
No, I'm referring to the 3 parties from which we need to save our data from.
vendors.
Okay. Okay, wait, somebody else. Second one. You'll get 4 chocolates, bro. Yeah. Yeah. Somebody else? Inside it? It is called insider threat, but you still get a chocolate. Okay, so the three main things are my vendors or tech partners, my malicious actors, my insider threats. So now what the system does is it provides an encryption key to something called authorized program. So this is a program which has the access to that encryption key, which means that it can encrypt the data and the code that modifies the data. So since the encryption key is not extended to any of these three parties, we have removed the access to our data from these three and restricted the access to just the authorized program. Now, imagine a scenario. What if a hacker tries to create an enclave on our system with like fake code in it and tries to steal some information? Or even better, as I just said that nobody has access to the data other than the authorized program. How do we even know that genuine code is being inserted in the enclave? Maybe somebody wrote a code to share our sensitive information with somebody else, and we don't even know about that, right? So there is something called Attestation Report. In the most simplest term, it's a way of just checking if the enclave is genuine and the code inside is genuine. And now, like this was all the lecture stuff. Now we'll go on to the cool stuff and see how this actually works. And we do not need to care about this internal mechanism on our own because platforms like the Google App providers, they automatically care about this. So basically the punchline is that collaborate freely without worrying about security. And when you run your code, you can be 100% sure that even Google doesn't have access to your sensitive information. Thank you.
Okay, has everyone got their subscription for the credits? Do everyone have it? Okay.
If at any point of time you are not able to follow her, just raise your hand. I'll come to you and help you out.
Let us go.
I'll join Zoom to help people on chat.
Yeah. So also on the people on Zoom, you can put your doubts in the chat. I will keep in mind to keep checking it if you have any problems. And just give me a second. So this is the lab that we're going to do. Google Cloud Confidential Computing, and it's a quick start. Can everyone find this lab? Just give me a second. Just raise your hands once you have found the lab, and people on Zoom, you can put it in the chat if you have done the lab. Has everyone found this lab? Found it? Found it? If there's anyone who couldn't find the lab, please raise your hand. Okay, Shyam, they haven't found the lab yet. Okay, I have a tip for you all. Just keep an incognito browser open, and if your computer allows it, open a split screen where you can see the instructions on the left and your incognito browser is on the right. So what I'm going to do is open an incognito browser. And I'm going to split the screen. Once everyone's reached this step, please let me know and we can move forward. Everyone on Zoom, have you been able to follow till this point? Okay, for those who have already found the lab, go ahead and click Start Lab. So yes, confirm that you're not a robot and say launch with 1 credit. Okay, so I have got my details here. So what I'm going to do is open this in a new tab and copy paste this address in my incognito browser. Okay, once I've done that, you should be able to see your student ID, which Google provides you, because it just gives you a limited access for 30 minutes because you are working in the real cloud environment and not a simulation or any duplicate. It's the actual Google Cloud platform that you will be given access to for 30 minutes as we do this lab. If you have any questions, please raise your hand. If some of you have reached this step, you can go ahead and enter your password, which is you have to copy from here and paste it. Click next, accept to the terms. Welcome to Google Cloud Platform. I found it pretty cool the first time I tried this, knowing that I'm having access to the actual Google Cloud platform that Google provides to us to learn. And we will work in this platform for the rest of the lab. Is everyone following? Is everyone able to reach till this point? Okay. People at the back, did you reach till this? Okay, great. So I'll just give you kind of an insight on what we're actually going to do in this lab. So what we're going to do is we're going to be making a virtual machine instance, which is going to be confidential, and a one that's going to be non-confidential. And we're going to run it in an SSH or a terminal and see what response a confidential VM is going to give and a non-confidential VM is going to give. And we're also going to be making confidential clusters and non-confidential clusters, which I'll get into more detail as we go through the lab. So go ahead to this navigation menu, open it, and you can see Compute Engine. At the Compute Engine, you'll see an option that says VM instances. As it loads, let me give you an idea of what Compute Engine is. So Compute Engine is this environment which Google Cloud has, which allows you to make extremely powerful VM instances. So VM is virtual machines. If there's any CS majors in this room, you'll know what a VM is. But for people who don't know what it is, I can give you an overview. It's basically having a virtual computer which runs on its own and behaves like a computer and hardware, but it's just virtually hosted. So does anyone here know what actually the cloud is? Like, we're working on Google Cloud. Everyone will say, oh, I've uploaded my photos to Google Cloud. What exactly does that mean? What exactly is the cloud? Anyone? Okay, I'll just tell you guys what it is. It's basically servers where data is passed through and they're accessed. So there are these data centers around the world which have these servers, and data is stored in those servers instead of our computer locally. So when you delete Instagram and then re-download it, you magically have all your data. It's because your cloud has all that data saved somewhere else and not locally on your phone or your laptop. So let's go ahead and create our own virtual machine instance on the Google Cloud. Hit create instance. So let's give this a name. Let's make this the confidential one. So this is my confidential VM. I'm going to go and see this option here, confidential VM service. This is where I'm going to enable the confidential computing service. So I'm telling Google Cloud that this piece of information or this piece of data or whatever is going to be on this virtual machine is going to be confidential and no one has access to this. So when a virtual machine like this is, when the creation of a virtual machine like this is successful, it kind of is like a sandbox effect. So one virtual machine is completely unaware of what goes on the other virtual machine, even though they're being run on the same physical hardware. So we just, after you enable the confidential computing service, go ahead and say create. So while this loads, you can check. I find this pretty cool. You can say, check my progress. And there it gives me a tick saying, I have successfully created a confidential VM. Has everyone reached this point? Okay. Okay, now we are going to be creating the non-confidential VM instance to create like a contrast to see what the non-confidential VM is actually going to give us instead of the confidential one. So let's go ahead and create that. In that, do you see these three dots here? You can find it there and say create instance. Call this one a non-confidential one. And let everything be as the default value and create the most basic VM and say create. So my instance hasn't been created yet. While we wait for this to be created, I can give you an insight of what we're going to do next. We're going to be creating clusters. So what basically a cluster means is you can imagine a top full of balloons. and the tub is called a cluster, and all the balloons are called nodes. Now imagine there are 3 green ones and 2 blue. So those 3 green ones will be called a node pool, and the other 2 blue ones are going to be another node pool. So what I'm trying to say here is the cluster is a big group that consists of nodes, and the nodes which have the same configuration is going to be called a node pool. So we are going to go ahead and create a cluster. So basically all the nodes are the VMs. So when you have to do cloud computing, you need to have access to multiple VMs. So I'm going to go ahead and create a confidential cluster. And then at the end, we'll see how a confidential differs from a non-confidential one. So I'm going to check my progress here. So every time you check your progress, you get 25 points. So keep doing that. Okay, now we have to, as everyone reached till this point, anyone's behind, please let me know. Yeah. Yes.
By just creating instance.
Yes, so we're leaving everything in default value. So we're just creating a default instance. And for the confidential one, we enable the confidential service that Google provides to us. So we actually explicitly state that we need this instance to be confidential and no one needs to have access to that. So even Google itself will not be able to access your confidential data, and that's what their service provides. So that's what we are trying to prove with this lab here. So let's go ahead and create a cluster. So go back to navigation menu and click Kubernetes engine. So you might ask me what Kubernetes engine is. It's just like a system that actually has these applications and everything, and it has Docker application and containers, as Shyam explained to us. The cloud computing works on containerized applications, and that's how it achieves confidentiality, because one container is not given access to the other container. So let's go ahead and Kubernetes engine and click clusters and say create. Just create the standard one and say configure. So I'm going to go ahead and name this confidential cluster. And since we are making it confidential, we have to enable, sorry. Yeah, so we need to enable this to be confidential. So for that, before that, let's do nodes pool, and we need to put the number of nodes as 1. So basically why we're changing the number of nodes is, number of nodes is usually the number of cores we require for the program to run. And since our lab is pretty small, we just need 1 node and we don't need much. Nodes pool, default pool, set the number of nodes to 1. Is everyone with me? Okay. Let's go to security. And that's where we will enable our confidential GKE nodes. GKE basically stands for Google Kubernetes Engine. So let's go and enable it to be confidential. So there it is. And let's say create. So my confidential GKE node is being created right now. And the non-confidential one is similar to the non-confidential VM instance. So that's going to be the default values for the clusters. So go ahead and create another cluster, say standard mode, configure, and let's call this the non-confidential cluster. And we will go to default pool, set this to 1, and say create. Everyone on Zoom, are you following? Let's check my progress for these 2. Okay, I got both of them. Has everyone reached till this point? Because now we're going to verify if my confidential cluster and my confidential VM instance is actually confidential and Google's not having fun with us. We're going to verify it using the SSH. if you are all CS majors, you have definitely tried SSH to connect to the CSI computers at Kemper Hall. So SSH stands for Secure Shell Protocol.
You can ask them.
Oh, it's okay. Has everyone reached till this point? People at the back? Okay, great. So from the navigation menu, go to Compute Engine and say VM instances. Over here, you can see all of my, whatever I created, my clusters and my VM, they're all listed below. Let's check the confidential VM first. Let's go to SSH, connect. And we are here with a very familiar looking screen, the terminal. And we need to put this command on the terminal. So this basically means diagnostic message, and this is a pipeline. And grep is used to filter out the results. And SEV stands for Secure Encrypted Virtualization. So we are checking if the diagnostic messages, if SEV is actually present in one of those, and if yes, it's going to print that. So let us copy paste this. Okay. Okay, so I'm going to copy paste this command and say, so there it is. The system has returned this line, which tells us that our data is securely encrypted and it is not accessible to anyone. It's the AMD memory encryption features are active, and SEV is secure encrypted virtualization. So the virtual machine that we created is securely encrypted and cannot be accessed by anyone. So on the contrast, let's go and find out. You can close this window. Let's go and find out the non-confidential VM. Sorry. Click SSH. So since it's non-confidential, it shouldn't be encrypted, and it should give me like an empty response saying there's nothing called encryption in my message, in my diagnostic message. So the command we wrote, DMESG, that means diagnostic message. So in the diagnostic message, it should not have anything that's encrypted. So we should expect an empty response. So let's see what it gives us. Sorry. There it is. We didn't get any response back saying that it wasn't encrypted at all. So that way we can prove that Google actually confidentially maintains our data. So we need to repeat the same process that I did for the confidential cluster and the non-confidential cluster. So I think you guys can try it. Go ahead and experiment this and see if the non-confidential cluster is giving you a response or not, and if the confidential one is giving you a response. If you have run into any trouble, please let me know. All you have to do is click SSH and run this command. A confidential one will give you something similar to the SCV. Otherwise, you should have an empty response. Yeah. Anyone who needs any help? But from my end, I think the lab is over. We proved that our instances are secure, encrypted, and no one's going to access it. So yeah, I think we proved that Google Cloud is actually trustable, and we can trust it with our data. We're uploading important documents up to the cloud. I think it's fair enough to say that it is confidential. And I'll hand over to Shyam for any questions that he wants to ask. But from my end, it's over. So if you have any doubts, if you ran into any troubles, please let me know. I'll come up and help you there.
Okay, some more opportunities to get chocolates, and these are just for participation. So it's not necessary that you answer them correctly. So my first question is, what do you call the data when it is stored in a storage device? Just raise your hand. Yeah. Exactly. Clapping. I guess you can assume what the next question would be. What do you call the data when it is being transferred from one point to another? Somebody in the back, please. Exactly right. What is the full form of SSH? No Google, no Googling. Exactly. I guess, what is the full form of GKE? No, it's Googling.
Is it the Kubernetes engine thing? Google Kubernetes?
Yeah, you got one more. What else can I ask? What do you call the isolated space within which the applications run? Somebody? Yep. What? Oh no, the isolated space in which they work is called enclave. But still, you get a chocolate for that. I guess that's pretty much from our side. Thank you very much, everybody, for attending the workshop. Hope you liked it. If you have any questions, please stay here and we can answer them. Thank you very much.
Yep, and just like one last thing, everyone. Another thing that we promised to talk about just at the start is SacHacks. They are, I guess, they're also co-hosting this workshop, which is like hosted. Like all three of us are both in SacHacks and GDSC. Don't ask me how that works. That's just the way it is. But yeah, so basically, SacHacks is going to happen in October. We're planning for it to happen around the 15th and 16th weekend. And basically, there will be some